thinking twice before you pick an external library. How working with right JavaScript libraries can help you boost speed and performance of your app. You are choosing library without checking what is inside. JavaScript development is like assembling applications out of a smaller blocks. To a certain degree, it is very similar to building React Native apps. Instead of creating React components from scratch, you are on the hunt for JavaScript library that will help you achieve what you had in mind. The JavaScript ecosystem promotes such an approach to development and encourages structuring application around small reusable module. This type of ecosystem has many advantages but also has some serious drawbacks. One of them is developer can find it hard to choose from multiple libraries supporting the same use case. When picking the one to use in the next project, they often search the indicators that they tell them if the library is healthy and well maintained, such as GitHub star, number of issues, contributors, and peer. What they tend to overlook is the library size, number of supported feature, and external dependency. They assume that since React Native is all about JavaScript and embracing the existing tool chain, they will work with same constraints and best practices they know from making web application. Truth is they won't, as mobile development is fundamentally different and has its own set of rules. For example, while the size of the assets is crucial in case of web application, is not equally important React Native where assets are loaded in the file system. The key difference lies in the performance of mobile devices and the tool used for bundling and compiling the application. Although you will not be able to do much about device limitation, you can control your JavaScript. In general, less code means faster opening time, and one of the important factors affecting the overall size of your code is libraries. Complex libraries hamper the speed of your apps. Unlike a fully native application, React Native app contains a JavaScript bundle that needs to be loaded into memory, then it is parsed and executed by the JavaScript VM. The overall size of the JavaScript code is an important factor. While that happens, the application remains in the loading state. We often describe this process as time to interact. It is a time expressed in hopefully the milliseconds between the when the icon gets selected from the application drawer and when it becomes fully interactive. Unfortunately, Metro, the default React Native bundler, currently does not support tree shaking. If you are not familiar with this notion, read this article. This means all that code you pull from npm and import to your project will be present in your production bundle, loaded into memory and parsed. That can have a negative impact on the total startup time of your application. How do we analyze bundle size? Keeping tabs on your React Native bundle size is important. We can use a React Native bundle visualizer to analyze the bundle. With the help of GUI, we can get the details of any added library in the bundle, hence deciding if it's worth keeping or removing that library. This package produces output using the app bundle in the following form. Be more selective and use smaller specified library. The easiest way to overcome this issue is to employ the right strategy for architecturing the project upfront. If you are about to pull a complex library, check if there are small alternatives that have the functionality you are looking for. Here's an example. One of the most common operations is manipulating dates. Let's imagine you are about to calculate an elapsed time. Rather than pulling down the entire moment.js library to parse the date itself, we can use day.js, which is substantially smaller and offers only the functionality that we are looking for. If there are no alternative, good rule of thumb is to check if you can import a smaller part of the library. For instance, many libraries such as Lodash have already split them into smaller utility sets and support environments where code elimination is unavailable. Let's you want to use Lodash map instead of importing the whole library as presented here. You can only import a single package. As a result, you can benefit from the utilities that are part of the Lodash package without pulling them all into the application bundle. If you'd like to have a constant insight into your dependency size impact, we highly recommend the import cost VS Code extension or using the bundle of OBI website. Your app has a smaller footprint and loads faster. Mobile is an extremely competitive environment with lots of applications designed to serve similar purposes and fights over the same customers. Faster startup time, smoother interaction, and the overall look and feel might be your only way to stand out from the crowd. You shouldn't downplay the importance of choosing the right set of libraries. Being more selective with third-party dependency may seem irrelevant at first, but all the saved milliseconds will add up to significant gains over time. Always remember to use library dedicated to the mobile platform. Use libraries dedicated to mobile and build features faster on many platforms as one without compromising on the performance and user experience. You use web libraries that are not optimized for mobile. As discussed earlier, one of the best things about React Native is that you can write mobile application with JavaScript, reuse some of your React component, and do business logic with your favorite state management library. While React Native provides web-like functionality for compatibility with web, it is important to understand it is not the same environment. It has its own set of best practices, quick wins, and constraints. For example, while working on a web application, we don't have to worry too much about the overall CPU resources needed by your application. After all, most of the website runs on devices that are either plugged into network or have large batteries. It is not hard to imagine that mobile is different. That's a wide range of devices with different architecture and resources available. Most of the time they run on a battery, and the drains caused by the application can be deciding factor for many developers. In other words, how you optimize the battery consumption both in the foreground and background can make the difference. Not optimized libraries no can cause battery drain and slow down the app. The OS may limit your application's capabilities, while React Native makes it possible to run the same JavaScript on mobile as in the browser. That doesn't mean you should be doing this every time. As with every rule, there are exceptions. If the library depends heavily on networking, such as real-time messaging, or offers the ability to render advanced graphics, it is very likely that you are better off going with a dedicated mobile libraries. Mobile libraries were developed with the web environment in the first place. Assuming the capabilities and constraints of the browser, it is very likely that the results of using web version of a popular SDK will result in external CPU and memory consumption. Certain OSs such as iOS are known to be constantly analyzing the resource consumed by the application in order to optimize the battery life. If your application is registered to perform background activity and this activity take too much of the resources, the interface of your application may get adjusted, lowering the frequency of the background updates that you initially signed up for. Use a dedicated platform specific version of the library. Let's take Firebase as an example. Firebase is a mobile platform from Google that lets you build your app faster. It is a collection of tools and libraries that enable certain feature instantly within your app. Firebase contains SDKs for the web and the mobile, iOS and Android respectively. Each SDK contains support for real-time database. Okay, thanks to React Native, you can run the web version of it without major problem. However, this is not what you should be doing. While the above example works without issue, it does not offer the same performance as the mobile equivalent. The SDK itself also contains fewer features. No surprise here, as web is different and there is no reason for Firebase JS should support for mobile feature. In this particular example, it's better to use dedicated Firebase library that provides a thin layer on top of dedicated native SDK and offer the same performance and stability as other native applications out there. So import database from React Native Firebase database. Here's how the above example would look like. As you can see, the difference is minimal. In this case, the library authors did a great job mimicking the API to reduce potential confusion while switching back and forth between the web and mobile context. Provide the fastest and most performant support with no harm to battery life. React Native is all about giving you control and freedom to choose how you want to build your application. For straightforward aspects and maximum reusability, you can choose to go with the web version of the library. This will give you access to the same features as in the browser with relatively low effort. For advanced use cases, you can easily extend React Native with a native functionality and dock directly to the mobile SDK. Such an escape hatch is what makes React Native extremely versatile and enterprise ready. It allows you to build feature faster on many platforms at once without compromising on the performance and user experience, something other hybrid frameworks cannot claim. Find the balance between native and JavaScript. See the harmony between native and JavaScript to build fast working and low maintenance app. While working on native modules, you draw the line in the wrong place between native and JavaScript extraction. When working with React Native, you are going to developing JavaScript most of the time. However, there are situations when you need to write a bit of native code. For example, you are working with a third-party SDK that does not have official React Native support yet. In that case, you need to create a native module that wraps the underlying native method and export them to the React Native realm, all the native methods need real world arguments to work. React Native builds on top of an abstraction called a bridge, which provides bidirectional communication between JavaScript and native worlds. There is an ongoing effort to move away from asynchronous communication to a synchronous one. You can read more about it in the new architecture chapter. As a result, JavaScript can execute native API and pass the necessary context to receive the desired return value. The communication itself is synchronous. It means that while the caller is waiting for the results to arrive from the native side, the JavaScript is still running and may already be up for another task. The number of JavaScript calls that arrive over the bridge is not deterministic and can vary over time depending on the number of interactions that you do with your application. Additionally, each call takes time as the JavaScript arguments needs to be stringified into JSON, which is the established format that can be understood by these two realms. For example, when the bridge is busy processing the data, another call will have to block and wait. If that interaction was related to gesture and animation, it is very likely that you have dropped a frame. The operation wasn't performed, causing jitters in the UI. Certain libraries such as Animated provide special workaround. In this case, use native driver which serializes the animation, passes it once upfront to the native tree and doesn't cause the bridge while the animation is running, preventing it from being subject to accidental frame drops while other work is happening. That's why it is important to keep the bridge communication efficient and fast. More traffic flowing over the bridge means less space for other things. Passing more traffic over the bridge means that there is less space for other important things that React Native may want to transfer at that time. As a result, your application becomes unresponsive to gestures or other interactions while you are performing native calls. If you see a degraded UI experience while executing certain native calls over the bridge, or seeing substantial CPU consumption, you should take a closer look at what you are doing with the external libraries. It is very likely that there is more being transferred than should be. Use the right amount of abstraction on the JS side. Validate and check the types ahead of time when building a native module. It is tempting to proxy the call immediately to the native side and let it do the rest. However, there are cases such as invalid arguments that end up causing unnecessary round trip over the bridge, only to learn that we didn't provide the correct set of arguments. Let's take a JavaScript module that proxies the call straight into the underlying native module. In this case of an incorrect or missing parameter, the native module is likely to throw an exception. The current version of React Native doesn't provide an abstraction for ensuring the JavaScript parameters and the ones needed by your native code are in sync. Your call will be serialized to JSON, transferred to the native side and executed. That operation will perform without any issues even though we haven't passed the complete list of arguments needed for it to work. The error will arrive in the next tick when the native side processes the call and receives an exception from the native module. In such a scenario, you have lost time waiting for the exception that could have checked for beforehand. The above is not only tied to the native module themselves, it is worth keeping in mind that every React Native primitive component has its native equivalent and the component props are passed over the bridge every time there is re-rendering happening, just like you execute your native code with the JavaScript argument. To put this into better perspective, let's take a closer look at styling with React Native apps. The easiest way to style a component is to pass it an object within style. While it works, you will not see it happening too much. It is generally considered anti-pattern unless you are dealing with dynamic values such as changing the style of the component based on the state. React Native uses StyleSheet API to pass styles over the bridge. Most of the time that API processes make sure they are passed only once over the bridge. During the runtime, it substitutes the value of the style prop with a numeric unique identifier that corresponds to the cache side on the native side, cache style on the native side. As a result, rather than spending a large array of objects each time React Native is meant to re-render its UI, The bridge has now to deal with an array of number which is much easier to process and transfer. Benefits: the code base is faster and easier to maintain. When you're forcing an performance challenges right now, it is smart to implement a set of best practices around native module, as the benefits are not just about the speed but also the user experience. Sure, keeping the right amount of traffic flowing over the bridge will eventually contribute to your application performing better and working smoothly. As you can see, certain techniques mentioned in this section are already been actively used in React Native to provide you a satisfactory performance out of the box. Being aware of them will help you create applications that perform better under a heavy load. However, one additional benefit that is worth pointing out is the maintenance. Keeping the heavy and advanced abstractions such as validation on the JavaScript side will result in a very thin native layer that is nothing more but just a wrapper around an underlying native SDK. In other words, the native part of your module is going to look more like a copy paste from the documentation. Comprehensive and specific mastering this approach to the development of native modules is why a lot of JavaScript developer can easily extend their application with additional functionality without specializing in Objective-C or Java. Animate at 60 fps no matter what. So we will look this chapter in the next video. Thank you. Bye.